Good morning. Now we are going to see about the fundamentals of modulation and multiplexing that can be used for voice, data and video communication in analog and digital form. So this class can be the fundamental to refresh all the basic concept related to analog and digital transmission. So first, what is the meaning of physical layer? Physical layer includes network hardware and software, you know that. So the network circuits include the physical media which can be used to support for the connections between the different devices. That network can be the physical or the logical network circuits. The physical circuits are responsible for providing the proper connection between the different devices by using the actual wires, and the logical circuits meant for the different characteristics of the different types of transmission characteristics like coding, etc., etc., that can be supported for data transmission within the network itself. The physical and logical circuit may be same or it can be a different. For example, if you take the multiplexing, the one wire can be used to carry the several circuits. Next, what is the meaning for analog and digital data? Another fundamental physical, this is the another fundamental physical layer distinction. So you know what is the meaning for analog and digital. So the whatever the signal we have received from the real-time application, right, from the environment. So all are related to the analog signals, but we are now processing those analog signals by using the computers in terms of digital, that is in terms of the binary which is having the combination of zeros and ones. And next the analog and digital transmission. So what is the meaning for analog and digital subs? If we have the data transmission continuously by using the analog form, then it is called as analog transmission. For the example, we can have the all sort of broadcast in radio and television. Whereas in digital transmissions, it is in terms of pulses which is representing the two defined levels. One is a digital 0 and digital 1. So all the nowadays computer networks, and even though the all sort of digital signal processing, it comes under the digital transmission only. So here we can have the analog to digital and digital to analog transmission, right? So when the digital data is transmitted over the analog medium, we should need the modem which is a combination of modulator and demodulator. But when we transmit the analog data over the digital transmission, we are in need of encoder and decoder, which that combination which is called as the codec, which is a combination of coder and decoder. So this tabular column mentioned the classification of the two types of data, analog and digital, in terms of the two transmission, that is analog transmission and digital transmission. So when we transfer the analog data over the analog transmission, then it is the example for radio and TV broadcast. Similarly, when we transmit the analog data in digital transmission techniques like pulse code modulation, etc. So that is called as the digital transmission. For example, it is example for video standards using codec. Similarly, for the digital data over the analog transmission, we are in need of the modem, and for digital data over the digital transmission, we are using the LAN cables. Then what are the advantages of digital transmission? So you know that the digital transmission represents the number of error is less, right, when compared to the analog transmission, because it is defined only in two levels, zeros and ones. So it is easier to detect and correct the errors. And here we can nowadays we have enjoyed the huge and higher level of data transmission because of the digital communication only. So about the analog transmission, here in the digital transmission we can have higher transmission data rate, and it is more efficient also, right? So accuracy is more, so it is possible to send more data through the limited spectrum which is available, right? That cannot be possible in the analog transmission, and it is also more secure, right? So nowadays we have plenty of techniques which is used for encryption and decryption, which is used to transmit the data over a long distance with a secure purpose, right? So we can have more security. And next, so this is the example for host space architecture. and this is the example for client-based architecture, right? So this is the example for this is for point-to-point communication, and this is the example for multi-point communication, right? So in the multi-point communication, what is the drawback? We have only one system can be used to the set of resources at a time, right? So others has to listen. That is the meaning. And here there are several ways for data flow. So it can be in one direction or it can be in both direction, right? So here by using these two categories, we can have simplex and duplex. Simplex means the data can be transferred in only one direction, right? Such as radio and cable television broadcasting. And duplex, it can be, you can have both listening as well as reading into, that means it is a two-way communication, right? So each and every device can be the sender as well as the receiver. That is the meaning for duplex communication. So in the duplex, we have half duplex and duplex. Half duplex means only one direction at a time. So at a time, a device can listen or it can read. That is, can listen or it can transmit. That is the meaning. Listen and read. That's the meaning for half duplex. But full duplex, here at a time the device can be able to listen as well as the read. That is the meaning, right? So this is a configuration which explains the different types of data communication. Starts from simplex. So here this arrow indicates that there is only one way of communication is possible. Here two-side arrow in duplex, it represents the two-way communication, but only one is possible at a time. But that is called as half duplex. But full duplex, we have both a transmission as well as a reception simultaneously. That is the meaning. In communication media, generally the communication media can be classified into two categories. One is the guided media and another one is the wireless media. Guided media means it is the meaning for wired communication. So generally we have used three types of the guided media for our communication. One is a twisted pair wiring, coaxial cable and optical cable. But nowadays we are in the wireless era. We know that is called as unguided media or radiated communication, where we have the electromagnetic wave propagation through the air. So the electromagnetic wave propagation is in terms of the radio communication, infrared communication, or microwave communication and satellite communication, depending upon the frequency range. And here in wired media, here we can have twisted pair as the best example for wired media. It is commonly used for telephone and local area network. So in that we have two wires which are all twisted together in order to avoid the electromagnetic interferences, right? So here and the shielded twisted pair can also be used, but it is more expensive, right? Generally the twisted pair cables are used for telephonic trunk lines applications. And coaxial cable we can have, we have used in many places, even nowadays also. So the main benefit of coaxial cable, it is very less prone to interferences than the twisted pair, right? This is the configuration of the coaxial cable, where we have the two conductors. One is the inner conductor and the other one is the outer conductor, and there will be an insulator in between the inner and outer conductor. And in the outer layer we have the cylindrical shell which is used to protect the coaxial cable from the environmental disturbances. And the last guided medium is fiber optic cable. So fiber optic cable, it is widely used and it is extremely high capacity because the signals are transmitted in terms of light by using the light emitting diode as the source or the laser as the source. So it is very basic and essential idea for broadband communication, right? So here, though it is most expensive, since it provides the broadband communication, nowadays the secured wired communication has been achieved by using the fiber optic cable only. And here there are basically there are two types of optical cable. One is the step index and the graded index. Again, depending upon the mode of configuration, the optical cable is further divided into two types, that is a single mode and multi-mode, right? So here the single mode, it is very difficult for manufacture, but the signal can be sent over a long distance and in terms of many kilometers without any spreading. Whereas in the multi-mode, it is very cheap. but you cannot avoid the spreading of the signal, right? That's why it is used for only short distances. And graded index multimode means it is used to reduce the spreading problem and change the refractive property of the fiber to refocus the signal, right? So when compared to multimode, step index multimode and gradient index multimode, we can be able to reduce the spreading of the signal by changing the refractive index of the fiber. So this is the configuration of different types of fiber. Single mode fiber, and these two are for multimode, and this is for step index, and this is for gradient index fiber. And here there are different types of, so as of now we have seen three different types of guided media, that is twisted pair, coaxial cable and optical cable. Similarly, here in wireless media we have, there are different forms of the communication in wireless also, depending upon the wavelength and or the frequency of the communication, like radio communication, infrared communication and microwave frequency communication. So radio communication means the wireless communication, the electrical signal is, if it is transmitted wirelessly, then it is called as radio communication. So the low frequency radio communication, it is called as, it is mainly supported for the application of AM and FM radio channel. And infrared, it is an invisible electromagnetic wave whose frequency is less than the light communication, right? That is the meaning for infrareds, and mainly we have focused for remote sensing, right? So remote sensing application. And the next last one is a microwave. It is a high frequency form of radio wave with extremely shorter wavelength in terms of centimeter to millimeter, and it is mostly used for all sort of radio, all sort of satellite, radar, military and defense applications. And here we know that the satellite application is one of the main application of the wireless communication, and that is by due to the microwave communication. So instead of transmitting from one terrestrial microwave dish to another, satellite communication can send from the ground to the satellite, or and vice versa, from satellite to ground. So the ground signal, it is sent to satellite, usually generally by using the geosynchronous orbit and over a long distance, that is up this level, and then the satellite will relay the signal and to this destination ground station. Right. So here in satellite communication, even though the signal is traveling at a light speed, the greater distance between the ground station to satellite means a large propagation delay occurs between the sending and receiving signal. So this is a diagram which explains the radiation of the satellite of longer distance or longer distance from the earth, revolving at the same speed as the earth rotated. And here there are different factors. So far we have seen different types of media, different types of signals. There are many factors which relies on the selection of media. So those are, that depends upon the type of the network, that depends upon the investment cost of the application, that depends upon the distance to be traveled, right? So the distance to be covered by the particular application, that depends upon the security level also, that depends upon the error rate also, and that depends upon the transmission speed also. So by considering all these factors only, we can be able to choose the media that is needed for the particular application in wireless communication. Thank you.